Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and let's jump into today's lesson. So today we're going to be doing Unit 3, Lesson 5. Don't forget to put your first and last name, period, and the date at the top right-hand corner of your notes. Today's topic is we're going to be learning how to factor difference of squares. So this is a special case scenario in factoring, and we're going to learn a different way to factor today. So today's objective is I will factor a difference of squares and check my final answer, because we always want to make sure that we're right? So what is a difference of squares? Well, what does it mean for a number to be a perfect square? Well, for example, 9 is considered a perfect square because 9 is really 3 times 3. Or what happens is 9 is the area of a square with side lengths of 3. So 3 times 3 would be 9. So that's why it's a perfect square. Just like x squared is a perfect square because it creates the dimensions of a square that would be x by x, and its area would be x squared. The same for numbers like 36, which creates a square that would be 6 by 6, or 81, which creates a square with dimensions of 9 by 9. Y squared creates a square with dimensions of y by y. So when I talk about a difference of squares, what that means is we take two perfect squares. So we have two perfect squares like x squared and 9, and we subtract them. So a difference just means subtraction. We take two perfect squares and we subtract them. So like x squared minus 9, or a squared minus b squared. A squared would create a square with dimensions a by a. B squared would create a square with dimensions b by b. And we're subtracting those two squares from each other, the areas of those two squares essentially. So the way we factor a difference of squares is we think about what is being squared in the first term. So what is being squared in the first term would be a. A is being squared here. Well, whatever is being squared goes here and here. Then whatever is being squared in the second term, in this case it would be b. B is being squared. That square is directly attached to the b. The negative is not included. You put whatever that number is here and here. Then you just have to remember that one factor has to be added and the other factor needs subtraction. So what we would have is a is being squared, so a and a. We would have b is being squared, so b and b. So our factors of a squared minus b squared are a plus b times a minus b. And we're always going to follow that rule. And we're going to do a whole bunch of examples in just a second, but let's just check and see if that rule is actually correct. Well, if I take a plus b times a minus b, so we're going to multiply it out and check just to make sure we're right. A times a would be a squared. A times negative b would be negative ab. Positive b times a would be positive ab. And then positive b times negative b would be negative b squared. Well, what happens to negative ab plus ab? These two terms are the same, except one's negative and one's positive. If you subtract something from itself, you cancel it out. So those middle terms cancel out. And we're left with a squared minus b squared, which is in fact what we started with. So we know our little formula is correct. So let's apply this to x squared minus 4. So remember, if you have a squared minus b squared, so two perfect squares being subtracted from each other, or a difference of squares, it always factors to a minus b times a plus b, or a plus b times a minus b. The order of factors doesn't matter because it's multiplication. So let's check this out. X squared minus 4. Well, 4 is really a perfect square, right? 4 would create a square with dimensions of 2 by 2. So I could rewrite this as x squared minus 2 squared. So when I set up my parentheses, I'm going to set up my two factors. I know one's going to be addition, one's going to be subtraction. So remember, whatever is being squared in the first term goes here and here. Well, what's being squared here is x. So I'm going to put x and x. Then the second term, whatever is being squared, goes here and here. So I'm going to have the 2 is being squared to get 4. So I'm going to have 2 and 2. X plus 2 and x minus 2. So let's multiply that out and check just to make sure that we're right. Well, x times x would be x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. So x squared, negative 2x plus 2x cancels, and we're left with x squared minus 4, which does match what we started with. So we know that this is our factored form of x squared minus 4. All right, why don't you give it a shot? So x squared minus 16. So rewrite 16 as a perfect square. What squared is 16? Then set up your factors. Remember, one needs to be positive in the middle, one needs to be negative. And pause the video and then press play when you're ready to check your work. So as you can see, I rewrote 16 as 4 squared. So I have x squared minus 4 squared. So my factors are x minus 4 times x plus 4. Part C. So part C at first doesn't look like it's a difference of squares. In fact, I have a perfect square here and a perfect square here, but they're being added. Well, remember, if your first term is negative, you always want to factor out the negative first. So you're going to factor out a negative 1, and you're going to get 49y squared minus 100. And I know that's right because a negative times 49y squared would be negative 49y squared. A negative times negative 100 would then be positive 100. So now we're going to rewrite these guys as perfect squares. So 49y squared could be rewritten as 7 squared y squared minus, and then 100 is really 10 squared. All right. So to set up our factors, we're going to put what is being squared in our first term? Well, 7 and y. So we're going to have 7y and 7y. Then what is being squared in the second term? A 10. So we're going to have 10 and 10. Then we're going to have a plus and a negative. So let's see if we're correct. So 7y plus 10 times 7y minus 10. Well, 7y times 7y would be 49y squared. 7y times negative 10 would be negative 70y. 10 times 7y is positive 70y. And 10 times negative 10 is negative 100. Well, what happens to those middle terms? They're the same. One's positive, one's negative. So they completely cancel. We're left with 49y squared minus 100. So we know we're correct. All right, so negative 18 plus 2z squared. So again, it doesn't look like we have a difference of squares. However, the first term is negative, so you need to factor that out. And then what's a number that goes into 18 and 2? So you need to factor out the GCF of 18 and 2 as well as the negative. Then you should have a difference of squares that you can factor and then check your work. Go ahead and give it a shot on your own. Press pause, then press play when you're ready to check. So as you can see for my factors, the first thing I factored out was a negative 2. The GCF of 18 and 2 is 2. And then the first term is negative, so I want to make sure I factor that negative out. After I factored out negative 2, I got negative 2 times 9 minus z squared. Then 9 minus z squared is a difference of squares, so I can use my little formula. I kept my negative 2 out in front, then I wrote my 2 sets of parentheses. 3 times 3 gets me that 9 squared. Z times z gets me that z squared. And then, of course, I made one of my signs minus and one of my signs positive. Then I multiplied it out just to check to make sure I was right. I distributed the 3 and then the negative z. I kept my negative 2 out in front, of course, with my parentheses. I simplified, I combined my like terms. So I got negative 2 times 9 minus z squared. I distributed that negative 2, and I did, in fact, get negative 18 plus 2z squared. All right. Now let's do part E. So in part E, 32x squared minus 8y squared. Well, 32 and 8 aren't perfect squares, so this doesn't look like it's a difference of squares. But 32 and 8 both have a GCF of 8. So let's factor that 8 out. So if I factor 8 out of 32x squared, I'm going to be left with 4x squared, because 8 times 4 is 32, and 8 times 4x squared is 32x squared. Then 8 times negative 1 is negative 8. So I know I'm going to have a negative 1 y squared. Now I have a difference of squares, because 4 is a perfect square, x squared is a perfect square, and so is y squared, and they're being subtracted. So I'm going to have 8 times. So 2 times 2 would get me 4. X times x would give me that x squared. So 2x and 2x. Then y times y will get me y squared, and then a positive and a negative. And of course, we can multiply that back out just to make sure that this is our factors. So we have 8 times 2x minus y times 2x plus y. So 8 times 2x times 2x is 4x squared. 2x times y is 2xy. Negative y times 2x is negative 2xy. Negative y times y is negative y squared. Well, 2xy minus 2xy cancel. 8 times 4x squared minus y squared. Distribute the 8, and we get 32x squared minus 8y squared. And we get what we started with, so we know we're right. So our factored form is 8 times 2x plus y times 2x minus y. Now it's your turn. Go ahead and do part F on your own. Press pause and then press play when you're ready to check your work. So there are actually 2 ways to do this problem. The first way is, I noticed that 4 is a GCF of 136, so I factored a 4 out, and I got 25x squared minus 9y squared. Then I saw that 25x squared and 9y squared are perfect squares, and they are being subtracted, so I have a difference of squares. So I can go ahead and do my factors. I keep my 4 out in front. 5x times 5x gets me 25x squared. 3y times 3y gets me, negative 3y times 3y gets me negative 9y squared. And then we can multiply that out and make sure that we're right. Or you could do it this way, because 10x squared and 36y squared are perfect squares already. 10 times 10 is 100, 6 times 6 is 36. So you could have had 10x minus 6y times 10x, 10x minus 6y times 10x plus 6y. There we go. Fix those signs. All right. So then, though, 10 and 6 both have a GCF of 2. So we can bring out a 2 out in front. And then 10 and 6 both have a 2 in common. So we can bring a 2 out in front. Well, this is multiplication. So I'm going to multiply my 2 by 2, which is 4, times this factor and times this factor. And lo and behold, that's the exact same answer that I got here. All right. Go ahead and flip the page over. These directions should say factor by grouping. All right. So these are just 4 examples to go through, or actually, I guess 6 examples to go through. A through D are all factor by grouping, and then part E and F are actually difference of squares again. All right, so let's do part A here together. So remember, to do factor by grouping, we multiply A times C. So 2 times 6 is 12. The factors of 12 are 1 and 12, 3 and 4, actually 2 and 6, and then 3 and 4. What factors of 12 add or subtract to get us B, which is 7x squared? 3 and 4 will work. So notice this time, though, we have 2x to the 4th, not 2x squared. 2x to the 4th, and then I can rewrite 7x squared as 3x squared plus 4x squared, and then plus 6. And now we have our 4 terms. So we're going to put our parentheses around the first 2. You're going to put a plus sign and then parentheses around the second 2 terms. Now factor out the GCFs. So the GCF of 2x to the fourth and 3x squared is x squared. And then we have, let's see here. 2x squared would be left, plus 3. 4x squared plus 6 have a GCF of 2. We'd be left with 2x squared plus 3. Well, hey, my parentheses match. So I'm going to put what's in the parentheses in one factor. So 2x squared plus 3, and then I'm going to put what's left in the other factor, which is x squared plus 2. And of course, you can multiply that out and check your answer and make sure you're right. All right, for part B, 2x to the fourth minus 3x squared minus 35. Go ahead and give that a shot. Remember to multiply a times c, make a factor tree for that, and then rewrite your bx squared term using factors of the a times c. Press pause and then press play when you're ready to check your work. All right, so for this problem, my factors are x squared minus 5 times 2x squared plus 7. And you can look through my work here to figure out what went wrong with yours or what went right. All right, so let's do part C. So part C is 6v cubed minus 16v squared plus 21v minus 56. What you might notice is a little different is that this polynomial already has 4 terms. So because of that, it's ready to be factored by grouping. We already have our 4 terms, so we just put the first 2 terms in parentheses. And then the second 2 terms in parentheses with the plus sign in between. And then factor out the GCF. So 6v cubed minus 16v squared. I think we have a, let's see, 2v squared in common. So 2v squared times 3v would get us 6v cubed back. And then 2v squared times a negative 8 would get us negative 16v squared back. 7v minus 56, I believe those would have a 7 in common, a positive 7, so plus 7 times, and then 3v minus 8. We'll check it out. Our parentheses match. So what's in the parentheses, 3v minus 8, goes in one factor, and what's left, these guys, 2v squared plus 7 go in the other factor. So the factored form of that polynomial is 3v minus 8 times 2v squared plus 7. All right, go ahead and give part D a shot. 21k cubed minus 84k squared plus 15k minus 60. So again, we've got 4 terms here already. You're ready to factor by grouping right away. Go ahead and give it a shot. Press pause and then press play when you're ready to check your work. All right, so your factored form of this polynomial should be k minus 4 times 21k squared plus 15. Look back at my work to compare and contrast yours from mine. So part E and part F, we're just going to factor these completely. So 81x to the fourth minus 1. This is a perfect square, and let me show you why. So 81 is really 9 squared. X to the fourth is really x squared squared. And then 1 is really 1 squared, because 1 squared is 1. So we've got a difference of squares here. So let's go ahead and write out our factors. So remember, what's being squared in your first term goes here and here. What's being squared in the second term goes here and here. And then, of course, you need a plus and a negative in between. So 9x squared plus 1 times 9x squared minus 1. So we actually can factor this even further because 9x squared minus 1 is a difference of squares again. So we can factor that actually. So 9x squared plus 1 is going to stay the same, but we're going to factor 9x squared minus 1 even further. So 9x squared, isn't 3x times 3x 9x squared? And then negative 1 times positive 1 will get you that negative 1. 9x squared plus 1 can't be factored further because it's not a difference of squares. They're just 2 terms being added together. So this method won't work. You have to have subtraction in between for it to work. All right, 16x to the fourth minus y to the fourth. Why don't you go ahead and give that a shot on your own? Press pause and then press play when you're ready to check your work. Remember to factor it completely. So I noticed that 16x to the fourth is really 4x squared times 4x squared. So we have a perfect square. Y to the fourth is y squared times y squared. So we have a perfect square. And they're being subtracted. So then one of my factors has a negative, one of my factors has a positive. But then I also noticed that 4x squared minus y squared is another perfect square because 2x times 2x is 4x squared and y times y is y squared. We need a plus sign and a negative sign in between. 4x squared plus y squared, while those are still perfect squares, it's not a difference, it's addition, so it's a sum of perfect squares. That can't be factored further. So your final answer should be 2x minus y times 2x plus y times 4x squared plus y squared. All right, I'll see you back in class.